Hello, my dear students. Once again, welcome back to your online class. So today, in this video, we'll be learning the last chapter of your physics textbook, that is the radioactivity. So there were many things that you had to study in this chapter, but in a reduced syllabus, you have only a few topics to be studied like the nucleus, the structure of the nucleus, atomic number, mass number, radioactivity, the properties of alpha, beta, and gamma rays, the harmful effect, and as well as the precautions, the background radiation, and finally, we'll learn a little about the nuclear energy. So to begin with the first topic, the nucleus, we have already studied that the central core or the central part of the atom is known as the nucleus. And the nucleus, it contains two kinds of nucleons, that is the positive nucleons, the proton, and the negative, that is known as the neutrons. Now coming to the structure. Okay, so we know that the atom in the center, we have a heavy mass, okay, which is known as a nucleus. So this is known as a nucleus, and the nucleus, it consists of the proton and the neutron, which are known as the nucleons. The proton is the positively charged particle and the neutron is a neutral particle, and around this nucleus we have the imaginary part in which the electron revolves. They are known as the cells. Okay, so now what is the atomic number now? So atomic number, it tells us about the number of protons. Okay, so the number of proton or even the number of electrons of a neutral atom is known as the atomic number. So if the atom, it has 5 proton, then its atomic number is 5. Now coming to the mass number, what is the mass number? The mass number is the sum of the proton plus the neutrons. That is the total amount of nucleons present in the nucleus is known as the mass number. Suppose if we have 5 proton and 5 neutron, then the mass number is written as 10. So generally, if we have any element x, okay, and then where do we write its atomic number? The atomic number is always written at the bottom, okay, atomic number. And where is the mass number written? The mass number is always written at the top as a suffix. So whenever you see this kind of expression, then the upper number, it denotes the mass number, and the lower, it denotes the atomic number. Now coming to the main topic, radioactivity. So generally in the nucleus, the number of proton and the number of neutron, they are almost equal. But when the atomic number exceeds 82, that means above lead. What happens above lead? The number of neutrons, okay, it greatly starts exceeding the number of proton. So such kind of atoms, when left in open or it just kept in a place, it starts to decay. Okay, so that process of decaying is known as radioactivity. So the radioactivity is the decaying of the element by the emission of three kinds of radiations, namely the alpha, beta, and the gamma rays. Like if you keep in a metallic chamber a small amount of a radioactive substance, okay, so here, and then if you keep the two metallic plate, okay, connected to a certain potential plus and the minus, and there are some photographic plates in front of this plate. So what happens, both of these plates will be affected, okay, because during the process of radioactivity the three kinds of radiations will be emitted, one moving towards the positive plate, one going towards the negative plate, and one with passing out without any deviation. So from this, it is clear that during the process of radioactivity, the three different kinds of rays are emitted. So the one that gets deflected in the positive plate must be a negative particle. The one that gets deflected towards the negative plate must be a positive, and this one is a neutral. Okay, so the positive particles are known as the alpha particles. Okay, generally represented by the symbol alpha. The negative is known as the beta, given by the symbol beta, and the neutral particle is known as the gamma rays. Okay, represented by a symbol gamma. So now we can define the radioactivity is the spontaneous process, okay, in which the radioactive substance, they decay by the continuous emission of alpha, beta, and the gamma rays. Now we know the properties of alpha ray. Now alpha rays are the positively charged particle, the beta is a negatively charged particle, and gamma is a neutral particle. Now one of the most common character between all of them are All of them, they are the electromagnetic waves. That means they can even pass through the vacuum. So now coming to the properties of alpha, the alpha ray can be compared to the doubly ionized helium atom. Okay, so doubly ionized helium atom means generally the helium, it has two electrons in the outermost orbit. So if you remove that two electrons, then it is known as a doubly ionized helium atom, that is He plus plus. Okay, or we can also write He, okay, 4 and 2, which can also be written as an alpha particle. So alpha particle, it has all the properties of the doubly ionized helium atom. Now coming to the beta particle, it can be considered as an electron, the high energetic electron. Okay, so having a 1 unit of negative charge. Okay, so this is a beta. And gamma, nothing more, but it's just the electromagnetic wave having a very high energy. So of all of these, the gamma ray, it has the highest penetrating power. So that's why of all of these rays, the rays are the most harmful rays. Now coming to the harmful effects of the radiations, so there are two kinds of effect. One is the short term and another one is the long term. The short term effect may be like a headache or loss in hair, okay, nausea, etc. And the long term may be like a cancer and a leukemia. And apart from that, the radiation also may cause the change in the genes. Okay, so that means the mutations may occur if you are exposed to the radiations for the long duration. Now, coming to the safety precautions. So, while working in the field where there are continuous emissions of the radiation, you must wear an apron which is coated with a lead. And whenever we handle the radioactive waste, we must use a long tongue so that we may not come in a direct contact with the radioactive elements. So now coming to the eighth topic, the background radiation. So we may be thinking that since we are not working in a nuclear power plant, so we are not exposed to the radiations. But it's not like that. All of us, we are continuously exposed to some amount of radiations, but the amount of radiations are quite low and it does not cause us any harm. So there are two kinds of background radiation. One is the internal source and the other is the external source. The internal source, it lies within our body. Like we have the isotopes of calcium, potassium within our body. It also emits a radiation, but the amount of radiations emitted by them are very less and it does not harm our body. And the external sources are like from the solar radiations. Okay, the radiation that comes from the sun, it also consists of some amount of harmful radiations like the cosmic rays and other rays that comes from the sun directly to the earth's surface. Now, coming to the last topic, the nuclear energy. So, we have studied about the nuclear energy in class 9 as well. So, the nuclear energy can be generated by the two processes, namely the combination of a two light nucleus to form a heavy nucleus, which is known as the nuclear fusion reaction. And the reverse of that one means the splitting of a heavy nucleus into the two light nucleus, that is known as a nuclear fission reaction. So during this process, there is a loss in mass, and the equivalent amount of mass is converted into the energy. So in this way, the large amount of energy can be generated by the help of nuclear fusion and a nuclear fission reaction. So you will be learning about the different properties of alpha, beta, and the gamma radiations. You'll be learning about the harmful effect. You'll be learning about the two kinds of nuclear reactions, and you'll also be learning about the nuclear structure, the atomic number, and the mass number. Okay, and if you have any problem, you're always free to contact me in my WhatsApp number. Thank you.